All right. So, thanks everyone for coming. My name is Jason Schadewald. I'm the Product Manager for Parasoft for Language Products. I'm standing here in the middle of Design West in San Jose, California. And today I want to talk to you about the MISRA guidelines. New version just came out for the 2012 guidelines. And we want to talk about not just what's different in those guidelines, but really how do you apply them in practice? And how do you make it work at an actual customer site with all the complications that MISRA themselves state exist? So first, a little background. Who's Parasoft? Well, we've been around for over 25 years, and we're privately held. We have no debt, no VCs. We kind of choose our own destiny from that perspective. We have some of the first patents in a number of software quality development testing technologies like static analysis, automated unit test generation, flow analysis, many things along those lines. Automated peer code review. And we're a global company. We have offices all over the world, thousands of customers, and we're happy to continue to serve them and see how we can improve software quality in general. So, who or what is MISRA? Well, MISRA is the Motor Industry Software Reliability Association. It's based in the UK. It's a collaboration between a number of organizations, mostly automotive industry, but also some consultancies and at least one university, Leeds University in the UK. Their goal is to improve the safety and quality of automotive software and make life safer for everyone who uses their vehicles. Now, more recently, they've been extending into aviation, aeronautics, and military, industrial sort of organizations, but what we find is they're most prominent in Europe, in the automotive industry, and lagging a little bit in the other industries. So who cares about MISRA? Well, you got a sense of it, mostly automotive. However, it is safety critical in mind. So you should see more people interested from the other industries. You should see more people from aeronautics. You should see more people from military, industrial, financial. Anything that has a safety critical application, anything that might harm human beings, you should really look at these standards, consider them for your own purposes, because they have a lot of really good ideas in there, a lot of ideas that you'll find a lot of static analysis companies have been espousing for a long time. And it's a really good thing to see an independent organization start to say the same things. So what's new in the 2012 guidelines? Well, first of all, they've introduced support for the C99 standard. It used to be in the MISRA C2004 standard, it was only C90. Now you have C90 and C99. Now, what does that mean for you in practice? It means that you have to choose which one you're going to use at the outset of your project and stick with that. As well, it determines which of the guidelines you're going to be following. Because some of those guidelines, you'll see they break down into their C90 based guidelines or their C99 based guidelines, or they're both. Number two, they have this directive classification. So what they've done is they've said, okay, there are certain rules that apply very well to static analysis type technologies, and there are other things, we're going to call them directives now, that are not easily defined. They require too much outside information to be statically analyzed. So we're going to talk a little bit about how do you approach directives when you've got some set of tools. The decidability and scope concept. So what they've done is for the rules, not the directives, but the rules, they've said each rule is decidable from a static analysis tool perspective or undecidable from a static analysis perspective. And then they've also introduced the idea of scope. How does this rule really apply? Is this at the single translation unit, or is this system level? We'll get a little bit into that. In particular, I'm going to discuss the undecidable rules. How does a static analysis vendor approach that, and how do you interpret that as a user? Last, this mandatory category. So in the past, again, in the 2004 standard, we had advisory and we had required. Now they've added mandatory. And the key about the mandatory guidelines is that you may not deviate. And we'll discuss in detail what does it mean to deviate, how do you deviate, and what are some strategies around deviations. So here's that view again from a more pictorial perspective. You can see that the shift from the old rules to the new rules, there are some more that have been added. They've broken out into the directives versus the straight up rules. And they've got that categorization with that new mandatory classification. Now, if you look a little bit more closely, you'll also see what this means in terms of deviation and in terms of compliance. When are you able to say, I've complied? Well, it's your choice, on or off for advisory, and then deviations even are optional. You may not need to say that I'm deviating from this rule in this case or that case. Although, I find that many organizations prefer to find a deviation strategy and stick with it regardless of which category the rule or a guideline belongs to. Now in required, you must use it unless you have a deviation. And now you can deviate specifically at a particular line of code or system-wide, project-wide, in which case you want to document it more broadly. And lastly, you have, in the new rules, mandatory, you may not deviate under any circumstances and still call yourself compliant with MISRA C 2012. Okay, so if you look at the actual text of this thing when it comes to directives, it'll say that they don't have the full description necessary to perform a check for compliance. Now, I'm not arguing with that per se. I think that there are still a lot you can do from a compliance perspective in an automated fashion. If you look at the problem a little bit differently, not just from the perspective of what can you do with static analysis, but what can you do with the broad array of quality tools you have at your disposal in a development environment, you can get a little bit further. And my example here would be all source files shall compile without any compilation errors. Okay, so there are two pieces to this. One, you have to know that you've compiled all of them. And two, you have to know that there are no compilation errors. Well, most organizations these days, and especially the mature organizations, have an automated build. They have a continuous integration build, and they have a scheduled build. Now, these builds produce build output, and here's where you can find the various errors, compilation errors from those builds. By the way, you've also confirmed, before getting to this point, that your compiler is compliant with MISRA. So now that you have your compliant compiler, and you have your automated build, and you have your build output, all you need to do at this point is scan that build output statically, find the compilation errors, and report them to some centralized database. Now that you have this information in a database, you can determine authorship, ownership, assign tasks, and get that remediated as quickly as possible. This is one way to demonstrate compliance when it comes to a directive, when you get a little bit outside of strictly thinking in terms of static analysis. And naturally, this is something that Parasoft does with our development testing platform. You can see here some of the build results, whether it's passing, failing, or compiler warning, and then tracking that over time by defining a policy. So what else? Well, now you got this directive about type defs that indicate size and that indicate signedness of your variables. This is an excellent, excellent strategy for a development organization to be following, especially if you're writing your code for multiple different targets, right? Because you get into a 64-bit world versus 32-bit versus 16-bit, and suddenly an int and a short don't mean the same thing. So what a lot of organizations do is will define these type defs, and they'll say, okay, well, this is my int 16, this is my uint 16, and so forth. Now, how you do that is quite variable. So MISRA is absolutely correct. You can't define this in terms of a static analysis rule right out of the box. You do need outside information from the user. So how do we manage this in practice? Well, we let you inform our tool. Now, a mature static analysis tool is parameterizable. It lets you say, my definitions live over here. I have this particular header file that works in these projects and that should be included in this way, and it defines them in this manner. And then you check that you're complying with the definitions in this file. So now you do have a decidable, statically based way to check that you're complying with this type of a standard, with this directive. Now, can we be 100% certain that you're following the rule? No. but that's why we introduce other methods such as code review, right? Now that you've got enough checks in place, you've got enough quality gates, you can be more and more certain that you're compliant. Okay, so let's get into decidability. I call this controversial partially for marketing reasons and partially because it introduces a controversy at the user end. From my perspective, as a vendor dealing with customers, if I say that I'm now supporting an undecidable rule, that I can find instances with my static analysis tool of something that's undecidable, that's going to cause them to have a little bit of an argument with me. Well, how can you possibly say that? Well, it's quite easy. We break it up into pieces, right? And the next slide is going to show this in a bit more detail, but before I flip over, I do want to say I'm not going to cover decidability theory in detail in this talk. We'll just say that the MISRA standard is based on the concept of decidability from the theory of computation, and they've restricted that definition from broadly all decidable processes to strictly what is decidable from a static analysis tool perspective. So to some extent, you'll see we can address this by getting outside of static analysis. To another extent, you'll see that we can subdivide it into pieces that are decidable and then leave the rest to other methodologies. In particular, let's look at these two rules that are undecidable. A project shall not contain unreachable code, and a project shall not contain dead code, or there shall be no dead code. So in this case, yeah, the general categorization, the general way that it's worded, you absolutely can't decide this. They're right. But now how do I attack it? As a user, as a vendor, how do I approach this kind of a problem when I know it's undecidable? I'm never going to be able to give you a 100%. Well, first, I can subdivide it into manageable parts that are decidable. I can look at it and I can say that, well, okay, unreachable code, I can't find absolutely all instances and be 100% certain, but I can absolutely find code that exists after a return statement, right? I can absolutely find a function that never gets called by any other method. And once I give you those and I help solidify those, now we look at the remainder of the problem. Now the remainder of the problem we can still manage by introducing a second type of static analysis technology called flow analysis, and that's actually examining paths through the code. So now I can say, well, I've gone through enough paths, I have a good sense maybe that this is not decidable. Sorry, this is not reachable. Even better, if I find a path that says, well, this if statement always evaluates to true, then I'm never going to get to the else. Right? That's dead code. That's useless code. What next? Well, peer review. Okay? And I don't just mean assigning tasks here to have one person review another's. I'm not talking about the tried and hated methodology of everyone sitting in a room and looking at their code and saying, yeah, you missed this semicolon here. I'm saying real contextual code review, where you assign this task and not only does it show you the diff with the code, not only does it show you the violation, but it also gives you these guidelines. It says right next to that task or right within your IDE of choice, by the way, check for these things. And now the developer, the reviewer, is able to go through and say, yes, I looked for dead code. Yes, I looked for unreachable code. So you see how we're using multiple technologies through a platform to say, I've done this incremental analysis, multiple methodologies to meet the guideline. So undecidable, absolutely. But does that mean unmanageable? Not at all. You can do this. Oh, and lastly, I love this one because you'll hear some vendors talk very much about false positives. False positives, false positives. Oh no, there's a false positive. Now, I'll grant you, maybe there's a way to write some of these rules that will be 100% perfect and never produce a false positive. And again, MISRA nailed this one perfectly. But there's also an ease of use aspect to this. If my perfect rule that will never give you a false positive takes days to run, that's not valuable to you. You can't apply that. Okay, so now, what if instead I give you a rule that will give you some threshold of false positives? I know in advance, yeah, it'll trigger on some things that aren't actual problems. Wouldn't you prefer that? Because this one runs in a couple seconds. And then you can just deviate. You can say, this is an exception to the rule. Life's easier for everybody. If you become overly focused on false positives, you're doing yourself a disservice.